We are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks. So without wasting any time, let's get started. But before that, if you have not subscribed the channel yet, please subscribe the channel and hit the bell icon so that you never miss any of these tutorials. Okay, alright. So today's problem is longest bounded difference subarray, which is marked as a medium level problem. Let's find out what we will be given into this problem and what we have to do. So we will be given two parameters. First one is an array ARR of integer type and second one is a variable X of integer type as well. Okay, and what we have to do. So basically this X is a threshold and we have to return the longest subarray. We have to return the longest subarray such that absolute difference between any two elements is not greater than x. Okay, all right. What does this mean? Let's quickly divide this problem into small steps. So first thing is, what is subarray? Subarray is basically a continuous part of an array. Okay, so if we talk about this 842 is a subarray, but if I say 42 and then 7, is this a subarray? No, because it is not continuous. Okay, first thing. After that, absolute difference basically means, let's suppose 3 minus 4 is equal to 1, which is 1, which is minus 1, but here 1 is the absolute difference. So in this way we have to consider it, and we have to return the elements of longest subarray such that like suppose this is our 4 to 6 is one of the subarray. We have to return this subarray only if like the elements, if we can take the absolute difference of 4 to 4 2 4 6 and then 2 6, so any of these pairs absolute difference should not be greater than x, should not be greater than x. If it is greater than x, I will not consider this subarray. If it is less than x, I will consider its length. And if I cannot found any other subarray with the length greater than 3, so this will be my answer and I will be returning 4 to 6 elements in a new array list. Okay, so this is what this problem statement means. Okay, all right. So if we see this, let's see the second example here where it is given 15 10 1 2 4 7 2. Okay, and x is equal to 5 basically means x is equal to 5 means ki I have to find that subarray such that the absolute difference between any pairs of that subarray should not be greater than x. Okay, so if I take 15 and then 10, so the absolute difference between them is what? 5. After that I take 1 as well, I include 1 into this subarray as well. So what is the absolute difference now? Maximum absolute difference, it is 14. It is 14. Okay, all right. So one thing you will be noticing here कि यार I don't need to calculate the absolute difference between all the pairs. I just need to find the absolute difference between the maximum and minimum value of the subarray, because if the absolute difference between maximum and minimum is less than x, so all the pairs difference will be of course less than x. Okay, I think you guys are getting this point. And so we just need to calculate the maximum and minimum elements difference in the subarray. Okay, so here it is 14, which means ki I have to decrease my subarray. So I will be like using two pointers. So I will increase my start. Okay, so now starting will be at this. Now starting will be 10. So again 10 minus 1, which difference is 9, which is greater than x. So again I have to decrease. So now I will move to this one. So now only one subarray is like one element subarray is there, which is 1. Okay, now I include 2 into this. When I include 2, so is this a valid subarray? Yes, because the absolute difference between the pairs is less than x, which is 1 only. Okay, I include 4 as well. Okay, and then I include 7 as well. So when I include 7, what is the absolute difference? Maximum absolute difference, it is 6 between 1 and 7. 1 and 7, so it is 6, but my threshold is 5 only, so I will not include this subarray. I will remove 1 from the subarray. Okay, so now our subarray is starting from, our subarray is starting from 2 4 7, and then I get 2 again. So should I include this subarray? Yes, I can include it. Why? Because maximum absolute difference between any pair is 5 only, and x is also 5, so we can consider it. Okay, all right. So I think the problem statement will be very clear to you as well. So Yeah, let's think of the approach one by one. I wanted to, like, one thing was coming in my mind and it is escaping. So whenever I will get that, I will tell. But I think the problem statement will be very, very clear to you. Okay. So one point which is very important is I don't need to, like, suppose 2472 is there. So I don't need to calculate the absolute difference between all the pairs. I only need to calculate the absolute difference between the maximum and minimum value. And if the absolute difference between the maximum and minimum value is less than x, so all the pair elements will be less than x. Okay, I think you guys are getting this point. So now let's think of the approaches one by one. The first approach which is coming in my mind is using a tree map, or like basically multi-set in C++ and tree map in Java, where I will be having, like, suppose a tree map is basically a hash map in which the keys are in the sorted order. Okay, keys are in the sorted order. So first of all 15 I get, then I get 10. So 10 will be stored first and then 15 will be stored. Okay, after, and the frequency of both is 1 1. Okay, so like in this way only map behaves na ki key value pair, but tree map and multi set both have a special feature that the keys stored are in the sorted order. Okay, so now after that when I get 1, it's like 1 frequency is also 1. Now I will get try to get the maximum and minimum value. So maximum minimum value is 1, maximum value is 15. The absolute difference between them is 14, which is greater than x. I cannot consider it. So what I will do, I will remove the first element, which is 15, from the map. Okay, 15 is removed. Again 10 1. So again the difference is greater, so 10 will be also removed. Only 1 is remaining now. Then I get 2. So 2 will be stored with frequency 1. In this way we will keep on having the checks, and we will get our answer. Okay, so this problem statement will be very, very, this problem approach will be very, very clear to you. The only issue is the time complexity of this is n log n, because we are using map, we are using a tree map to sort it. So we are considering, let's suppose if I consider three elements, so the total frequency will be, oh, total time complexity will be n log k, and in the worst case it will be n log n. Okay, all right. So this is the first approach, and I think in log k time complexity we can make it better. We can make it better. How we can make it better? Let's understand. So if you remember the last problem which I have explained, like the previous problem of the day. If not, please watch my tutorial on of that as well. So like this problem is an extension. This problem is an extension of that problem only. Okay. So like if you remember the previous approach I just told, that we will be using a tree map to store to get the maximum and minimum value. Okay, because if the absolute difference, again I'm saying, if the absolute difference between the maximum and minimum value in the subarray is less than x, so all the pairs difference will be less than x and we can consider it. Okay, so if I can get somehow get the maximum and minimum value, um, if I can somehow get the maximum and minimum value without using a tree map, it's a golden thing, because we don't need to sort it as well now. So we can get it. How? Let's quickly understand it. So I will be using a DQ. I will be using a DQ. DQ is present in both C++ and Java. And what this DQ allows? DQ allows to insert the elements and to remove the elements both from the starting as well as the end. Okay, so that's what this means, DQ. Okay, now what I'm going to do, let me copy this test case and move to OneNote where it will be easy to explain. uh, let's quickly increase the size of it and remove this link. X is equal to 5. Okay, all right, let's go. So what I'm going to do, I'm going to use a DQ. Why? I have already told you. So what will be my approach? Look, at any point I will be having two DQ. I will not be having one DQ, I will be having two DQ, and each DQ, first one is the min and second one is the max. So at any point, the first, let's suppose for the max DQ, first element will be containing the maximum element in that subarray, and in that subarray whatever I'm considering, and in min DQ the minimum element of that subarray will be stored. How it will be possible without using sorting and all? Let's quickly understand that as well. So what I'm going to do, yeah, suppose I am at 15. Okay. So what I'm going to do, first of all, I'm going to add this. Look, I'm not going to add value. I'm going to add indexes. Why? Because let's suppose 15 is stored and now 10 also I got, and then I get 1. So now the difference is greater than x. Minimum and maximum value difference is greater than x. So I have to remove this 15. How can I know what index? Because I have to remove it index wise. So how can I remove get like what is the index of it? So that's why I'm storing the index, and the value I can easily get by ARR of index. Okay. So first of all, what I get 15. So I will add this 0 index 0 in both max and min. Okay. All right. After that, I get 10. So look, max subarray, max DQ at any point will be giving me the maximum subarray till that point. Okay. So now when I get 10, this one index will also be added because its value is less. Okay. But in min dq, this 0 will be removed, and now only one value will be remaining. Why? Because 1 is the smallest in this. Okay. So I can easily have a check ki yaar, if ARR please listen to me with very concentration. If ARR of min dq dot last is greater than greater than the current element, which is 10. So like 15 is greater than equal to 10. Yes. So I don't need to consider, I don't need to like store 15 now, because I will be min dq will be always pointing to the minimum element of that subarray. Okay. So which is 10. I think you guys are getting this. So now 1 is stored. Okay. After that, my length, I will be having one variable as well, which will be my max length. And max length is currently what, 2, and start is at 0, so that at last we have to return an array list. So I will take use of this start and max length. Okay. All right. After that, what I get 1. So when I get 1, so look, this 2 will be added here because still my greatest element is 15, which is at 0 index. Okay. But here 1 will be also removed, and only 2 index will be there because now 2 is the minimum. Okay, okay, okay. All right. I think you guys are getting. Now what I'm going to do, I'm going to get the, let's suppose for after every addition, I'm going to check your maximum value and minimum value. Is there difference less than X? If yes, uh, increment this. Otherwise, we have to remove some elements from the starting. Because then only I can have subarray, because now 15, 10, 1, this subarray is not valid. Okay. So that's why now 2 is there. Okay. So I have to remove some elements. Currently, my starting at 0. So until max and min difference is greater than x, I am going to remove elements from the starting. Okay. So uh, like first of all, this starting I will be increasing now to 1. So if any index less than 1 is present in min and max, it will be removed. In min it is not present, in max it is present. Okay. So this will be removed. Okay. After that, again, now look, still ARR of one index, which is 10, minus ARR of two index, which is 1, is greater than x. So this 1 will be also removed. Okay. Now starting is what? Starting is 2. I guess you guys are getting what I'm saying. So now only 1, this is present. Okay. All right. After that, what I get? I get 2. I get 2. So now you see key is still. So look, these two elements are now ignored. These two are processed. And now my current subarray is starting from 1, because the starting index is 2, which is this. Okay. So from 1 it is starting, and now I get 2. So when I get 2, you see key now uh, like minimum is still 1, so this next index will be added here. But in maximum, now maximum is 2, but here maximum is 1, so it will be removed from here, and now only two index is what? 0, 1, 2, 3, 3 will be added. All right. Again, I'm going to check the maximum and minimum difference. Like it is 3 here, it is 2 here. The array is also 2, 1, so the difference is 1. All right. Okay. Again, I get 4. So when I get 4, minimum element is still at 2 index, so 4 will be added at later. But here in the max dq, now maximum element is 4, whose index is 4. So it will be stored in the very starting, because at any point the starting of min dq is representing the minimum element of that subarray, and maximum element of that subarray is represented by max dq. Okay, all right. So 4 and 2. Again, I check the difference. Difference is 3 between them, which is valid. Now my max length is increased to 3. My max length has increased to 3. Okay. After that, I get 7. When I get 7, again, you see कि यार fifth index minimum is still at 2 index. Okay, so min dq I will simply add 5 at the last. But 4 here, now min dq is 5 because 4 is not the maximum again. So I will check the difference between these two. ARR of 5 is 7, ARR of 2 is 1, which is difference is what, 6, which is greater than 5. So I have to remove some elements. Okay, how can I remove some elements? I will first of all increase my starting. My starting is now increased to 3. Okay, okay, my starting is now increased to 3. So if any element in the minimum starting and maximum starting is less than 3, I will remove it. Yeah, this is less than 3, I will remove it. Okay, after that, again, yeah, do I still need to remove some elements? No, I do not need. Why? Because ARR of 5 is 7, ARR of 3 is 2, difference is 5, which is okay. Okay, all right. After that, I again get 2. So you see my starting is now updated to 3, which means my new subarray is starting from here, and now I get this 2. So I will add it. How I will add it? 6. So look at this is pointing to minimum elements. So do I need this 5? No. Do I need this 4 anymore? No. Because these are greater, and now I have got a element which is less, which is at 0, 1, 2, 3, 4, 5, 6, 6 index. Okay, so all of these will be removed, and now only 3 and 6 are there, and 6 is added here as well. Again, difference between the subarray is what? ARR of minimum is 3, ARR of maximum is 5, which is okay. So now my max length is increased to 4 because the new subarray is 2472, and I will simply run a loop in the very last, from starting to starting plus max length, add all the elements and return. I think the problem statement, the intuition behind it, why we are using two DQs, min and max, what is the purpose of it, how we are using this max length and starting, how are we updating it, will be, everything will be very, very clear to you. So now let's move on to the code section, and believe me, when I am going to write the code step by step, this problem will be crystal clear to you. But before that, if you have loved my explanation, if you have loved my approach, guys, please subscribe the channel and like the video. I'm requesting you because I'm making this video at midnight, and if you will subscribe, it will really, really motivate me a lot. Okay, all right, so now let's start. Let's go. First thing what I'm going to do, I am going to have a few variables. First of all, let's declare two dq of integer type, and its name is max dq. Let's write dq. Okay, which is correct as well. New linked list, because this dq interface is implemented by linked list class in Java. Okay, and guys, if you are coding in C++, no issue. I will upload the C++ code on my GitHub as well, and believe me, that if you know the logic, you can write the code by yourself as well. Okay, all right. Now I will have few variables. First one is, let's suppose, starting of my subarray, which is currently 0. Okay, and max length is also currently 0, and like, look, this starting will be saying like current starting, but my answer start will be also 0. Answer starting will be the answer, like from where I'm going to start. Okay, all right. So now basically use a for loop. Let's declare the int variable as 0. So this starting at any point will be representing my subarray starting, and ending will be representing the ending. Okay, all right. So now let's say ending is less than ARR dot length int plus plus. Okay, so first of all, I need to update my max dq and min dq. How? Let's quickly see that as well. So yeah, look, while not max dq is empty. Okay, and then max dq first element will be always representing the maximum element of that subarray. So if there are any element which are less currently than current element, like if there are any element present in this dq which are less than my current element, I will remove them because there is no need. Like if it is less, so will it will never be considered because I have now got the greater element. Okay, so that's why I think you guys are getting this. I have already explained why. So arr of max dq dot peak last is less than arr of end. So it means these elements max dq last is of no use, so I will simply remove them. How I'm going to remove them? Max dq dot pole last. Okay, all right. And after that, when I will come to here 22 line, what I'm going to do, I'm going to add my current index. Look, index is max dq dot peak last is index, so that's why I'm using an array to access the value. Okay, so now I'm going to simply do max dq dot add. In the last, I will simply add what? I will simply add end. Okay, same thing I am going to do for min dq, but here instead of checking is less than, I have to check the greater than. Okay, so min dq, let me quickly copy it, paste it at several places like this, and just change the sign here. Okay, so what this will say, this will say ki, look, if my current element, let's suppose arr int is 1. Okay, and like max dq will always be representing the minimum element in the starting. Okay, so now suppose I get 1, which is minimum, but in my in my dq, in my min dq, there are elements present like 5, 4. So is there any need to store 5 and 4? No. Why? Because I've got the minimum now. So all those others are having no sense. Okay, all right. So these two are updating, and now I just need to check one more thing. What is that thing? Ki yaar, uh, is the difference between max dq and min dq greater than x? If yes, I have to remove some elements. How I'm going to check? Let's quickly see. While arr of max dq dot peak first of max dq will be representing the maximum element of that subarray. Okay, so max dq is minus, let's copy this again, let's name it as min dq. And guys, I think you guys are getting this. If yes, please subscribe the channel. And is if it is greater than x, so I have to update few things. I have to update few things. What I'm going to update? Look, first thing is, now I will be updating my start. Okay, so now start is increased. So my, if max dq and min dq are storing having any indexes which are less than start, I have to remove it because my subarray starting is now updated. So no need to add any outdated values in min dq and max dq. Okay, so if max dq dot peak first is less than start, simply remove them. How? Max dq dot pole first, and that's it. Okay, so same thing I will do for min dq as well. All right, okay, so these are also done. And now I am coming to 33 line. In this line I will simply check key. Look, if what, if my end, current end minus starting plus 1, this is the length of my current subarray which is valid, is greater than max length. If it is greater than max length, I have got my new answer. I have got my new possible answer. So simply first of all update my max length to end minus starting plus 1, and update my answer starting, to current starting as well. Okay, all right. After that, coming out of this while loop, here at 40 line, what I am going to do, I'm going to make one array list answer is equal to new array list, and simply run a for loop. Int I is equal to 0. Not 0. I is equal to best. I is equal to answer starting. I is less than answer starting plus max length I plus plus, and simply add the answer dot add arr of I, and after that I will simply return my answer array. So that is it, guys. That's it, what we have explained, what I've explained, what it is coded. So if you want to see what I'm doing here, so let's suppose my max will be my answer starting for this will be one index, and my on max length will be 3. So 1, like start the loop from 1 and run it till 1 plus 3 4. 1, like 1 to 4, and 4 is not included. So 1 2 3 index values will be added to the answer and will be returned. Okay, all right, I think the everything will be clear. Let's quickly try to directly submit it. And guys, the time complexity of this approach is big O of n, because I'm iterating over this array only once. You can see it here. And the space complexity is also big O of n, because I am using max dq and min dq. Okay, all right, so that was it for today. I think you guys will have got this approach, and you will definitely subscribe the channel, like the video. This code you will get on my GitHub. Make sure to follow me on GitHub as well, yeah. And if you get a better solution, make a merge request of this repository, and I will definitely merge that. Okay, so that was it for today. I'm going to see you again tomorrow. Till then, keep on coding, like the video, comment, subscribe, share, and that's it. Bye, guys.